In the green, rolling hills of Ayrshire, Scotland, a young boy named Alec Fleming was born. This was in 1881. The world around him was not one of gleaming laboratories. It was a world of nature, of wild things. He grew up on a farm called Lockfield. Here he learned the rhythms of the land. He watched the seasons change. He observed the plants and animals with a keen eye. This was his first classroom. It taught him to look closely, to notice the small details that others might miss. This habit of careful observation would, one day, change the course of human history in a most remarkable way. His education began in a small moorland school. It was a simple place, but it was here that his mind was sharpened. At the age of 13, he left the quiet hills of Scotland behind. He moved to the bustling, noisy streets of London. He enrolled at the Royal Polytechnic Institution. He was studying business, but his heart was not in ledgers and accounts. To understand the miracle of Fleming's discovery, we must first look at the world before it. It was a world of fear, a world where a simple cut could be a death sentence. Before the 1940s, there were no antibiotics. Surgery was a gamble. Even with the most skilled surgeon, the greatest threat was not the operation itself, but the infection that so often followed. The great wars of the early 20th century made this problem tragically clear. On the battlefields of World War I, far more soldiers died from infected wounds than from bullets or shells. A soldier might survive the initial injury, but a piece of shrapnel or a bullet would carry dirt and bacteria deep into the wound. Gangrene, a terrible infection that rots living tissue, was common. The only treatment was often amputation. This constant struggle against infection was the central challenge of medicine. Scientists were desperately searching for a magic bullet. They dreamed of a substance that could hunt down and destroy harmful bacteria inside the body. But without harming the patient's own cells, the world was waiting for a breakthrough. It did not know that the first clue would come from a moment of sheer, beautiful luck in a cluttered London laboratory. Alexander Fleming's journey into medical research was not a straight line. After deciding to study medicine, he enrolled at St. Mary's Hospital Medical School in London. Fleming joined the inoculation department at St. Mary's in 1906. It was a place of great excitement and innovation. He learned the meticulous techniques of bacteriology, how to grow bacteria in glass dishes, how to study them under a microscope. He was a natural. The moment of discovery arrived on a late summer day in 1928. He had just returned from a 2-week family holiday. One dish caught his eye. It was contaminated. A speck of mold, a bluish-green fungus, had somehow drifted in and started to grow. Around the patch of mold, there was a clear, empty circle, a zone of death. The bacteria were gone. It was as if the mold had put up an invisible barrier. Fleming stared at the dish. He knew he was seeing something profound. He famously said, "That's funny." He carefully picked up the dish. This was not just a ruined experiment. This was something new, something powerful. The mold was producing a substance that could kill one of the most dangerous bacteria known to man. The search for a magic bullet had just truly begun. Fleming's initial reaction was quickly replaced by intense scientific focus. His first step was to isolate that mysterious mold and produce more of the magical substance it was creating. He identified the mold as a member of the Penicillium genus, and with simple logic, he named the active substance it produced penicillin. The results were astonishing. Penicillin was incredibly effective against a wide range of bacteria, the biggest killers of the time. In the late 1930s, a team of scientists at Oxford University began to look for new antibacterial agents. They came across Fleming's old paper from 1929. The Oxford team succeeded where Fleming had not. They used bedpans, milk churns, and even a bathtub to grow the mold. Eventually, they managed to produce a small amount of a stable brown powder. It was impure, but it was penicillin. In 1940, they conducted a famous experiment. They infected 8 mice with deadly streptococci bacteria. They treated 4 of the mice with their new penicillin powder. The next morning, the 4 untreated mice were dead. The 4 that had received penicillin were all alive and well. The miracle from Fleming's dish was finally ready for the world. By 1943, penicillin was being produced in large quantities. It was a top-secret military project, with the first priority to treat wounded soldiers. On the battlefields of World War II, penicillin changed everything. Soldiers who would have died from gangrene or other infections were now saved. After the war, penicillin became available to the public. For the first time in history, doctors had a weapon that could cure diseases that had plagued humanity for centuries. Alexander Fleming was not a typical hero. He wasn't loud or boastful. He was a quiet, modest man known for his germ paintings at the Chelsea Arts Club. He would paint simple scenes using different species of pigmented bacteria, a charming and unique hobby that showed his creative side. His lab was legendary for its untidiness. It was a creative chaos that would have horrified a more organized scientist. But this very untidiness played a crucial role in his greatest discovery. Fleming's legacy is twofold. He is remembered for the discovery that saved millions of lives, but also for a lesson in scientific thinking, the legacy of observation and curiosity. As Louis Pasteur said, chance favors the prepared mind. Fleming's mind was prepared by a childhood spent observing nature and a career studying the unseen world of bacteria. The discovery of penicillin ushered in the antibiotic age, but it also brought new challenges. The overuse of antibiotics has led to antibiotic-resistant bacteria. Every person who has ever taken an antibiotic for a serious infection owes a small debt to that moldy dish. It teaches us to value curiosity, to embrace the unexpected, and to look for wonder in the forgotten corners of our world. A simple, accidental discovery gave humanity one of its most powerful tools against death and disease. It is a beautiful testament to the power of a prepared mind and the strange, wonderful workings of chance.